mathematicians, let's do your homework. Okay, just because we were talking about dividing in decimals, do not automatically assume that every single one of these problems is division. Some of them are multi-step, some of them are just not division at all. So we have to read closely. Jasmine spends $77.70 on 6 colored shirts for work. If each shirt costs the same amount, how much was each shirt? So we talked about each can be a keyword for multiplying or dividing. This one is giving us the cost of 6 shirts, and it's asking for the cost of 1 shirt. So usually when you have a question that's saying how much is 1, that is a division problem. So this one, we're not going to go into the store and buy half a shirt, but we can spend half $1. So if you can cut it in half, it can go inside your division house, and the shirts will go outside. So this problem, you're just going to divide as if this was 7,770. That decimal, you can even erase it to the roof right now. And now you're going to ask yourself, okay, if I had $7, can I buy a $6 item? Yes, I can. I can buy one of them. You're going to subtract. You're going to see what your remainder is. You're going to bring down the next number. You need to keep going. So this one is division. Alyssa bought a bottle of soda that contained 100 fluid ounces. If 1 serving of soda is 8 ounces, how many servings does this bottle contain? So if you can't picture it, we've got like a bottle. Ooh, check out my art skills. There's our bottle. And it has 100 fluid ounces. I'm asking how many servings. Here's 8 ounces. Here's 8 ounces, which, by the way, 8 ounces is the same as 1 cup. 8 ounces. We're trying to figure out how many 8 ounces is, not the way you say it, fits into 100. So this is also a division problem. 100 split into groups of 8 ounces in each group. Frankie's grandma gave him $100. Thanks, Grandma. He decides to buy 8 packs of Pokemon cards. Each pack, that either tells us we're multiplying or dividing, costs $7.99. How much will he have left over? Ooh, this is a 2-step problem. Because first of all, 1 pack of Pokemon cards, what's on a Pokemon card? Oh, that this thing. 1 pack of Pokemon cards costs $7.99. But we want 8 of these. We want 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have to multiply the cost of 1 times the 8 packs we're going to get. That's going to give us an answer. If you make it 799 times 8 and then you move your decimal in 1, 2 places, then that will be your answer for how much he spends. But then you have to subtract because he starts the day with $100, which we can write as $100.00. And then you're going to subtract away how much you spend, which will be this answer. So that answer will move down here. And this will be your final answer for the problem of how much money he has left over. Jerry is choosing between 2 different sizes of paint cans at a home improvement store. He can spend $25.50 on a 30-ounce can, or he can spend $49.75 on a 60-ounce can. Which one is the better deal? Ooh, I love these types of problems. This is where I use division most in my real life, because I'm not trying to spend more money than I have to. So what we're figuring out here is which one is going to be cheaper for the same amount of stuff. You can't just say, oh, this one's cheaper because that's less money. Yeah, but it's also less paint. So you need to compare them at the same amount of paint. The cool thing about these types of problems is they are probably trying to set you up to do, it's called a unit rate. For every 1 ounce of paint, how much money is it? So you could go with option 1 and option 2. Option 1 is saying, okay, we have $25.50 for a 30-ounce can. Ounces is abbreviated OZ. Or option 2 is $49.75 for a 60-ounce can. So one way to check these, the way that this problem is trying to get you to do it, is to find the unit rate. You divide $25.50 by 30 ounces, and this will be the cost per ounce, the cost for every 1 ounce. And you can do that here and divide by 60, and find the cost per ounce and then compare those two answers. You can compare those two answers because they're both the cost for 1 ounce. However, this is a hint only for the video viewers. You could also say, okay, 30 ounces is $25.50. How much would 2 of these cans cost? Because then you'd have 60 ounces. So if you figure out how much this is, you can compare it to this number, $49.75 for 60 ounces, because you'll be comparing 60 ounces to 60 ounces. So you don't actually have to solve these types of problems with division. So long as you're comparing at the same amount, you can compare them at any number. You could cut option 2 in half, divide it by 2, and then you get an answer that's 30 ounces, and you can compare 30 ounces for 30 ounces, because then you're getting the same amount of stuff, and why would you pay extra for the same exact amount of stuff? So that's what you're going to be comparing, and your ultimate answer is not going to be a number, it's going to be an option. Option 1 is the better deal because it's cheaper, or option 2 is the better deal because it's cheaper, and cheaper means less expensive for the same amount of stuff. On the back, we're no longer working strictly with decimals. This list is fractions, decimals, and mixed numbers. There will definitely be questions like this on the quiz on Friday and on the test next week. Least to greatest. I start by just looking at the whole numbers. Is -6 smaller than -5? Well, yes, it is. Is -5 smaller than +6? Am I going to have to figure that one out? Yep. But 7 is bigger, so it's looking like, okay, we're trending in the right direction. Here, I can automatically cross G off because no, our least to greatest does not go negative, positive, positive, negative. G is definitely wrong. Same deal with H. What's that positive doing in the middle of my negatives? Oh, actually, I don't think we need to do any real converting of any decimals and fractions. Is -5 smaller than -6? No. Look at that. That's why it pays to test each one, kind of think it through before you get into the nitty-gritty of 6 1/4 is really 6.25, and 46 divided by 7. What is that? Like, we didn't actually need to do that. And yeah, if we did it, we'd still get the same answer, but we're trying to think efficiently and recognize patterns so that we don't have to do all the work. Next up, which one has an answer of -9? You can solve that one. Which problem below has the greatest answer? Ooh, that does mean you have to solve all 4 answers before you can pick. Because unlike option 6, where the minute you see one that equals -9, you're done, here you have to actually have an answer for each of these, and then you can look at those 4 answers and decide which one's the biggest. Which of the problems has an answer of 10? Ooh, again, this one you don't need to solve all of them. You just need to get to the point where you're like, okay, this one is -10. That's a no. And once you get your yes, you're done. So if your yes comes before letter D, then you're good. Last but not least, oh, this one's a multiple choice. I shouldn't have made it a multiple choice. I should have just made you do it. This dot right here means multiply. Multiplying comes before adding. So we're going to multiply these two numbers. -2 times -6. 2 negatives multiplied makes a positive, and that is 12. 12 plus 10, oh, you can do that. There's only one answer that even remotely looks like it could be the answer, even if I didn't actually know off the top of my head what that was. There we go. And now we're done with our homework.